Hi, just a reminder that all the programs that I discuss in the video have links in the description. You could click and check them out. And do subscribe if you haven't done so already. We start with an introduction to Python modules. We're going to look at math, statistics, and random modules. Any code written in Python and saved with extension .py is a module. Python's standard library also provides many inbuilt modules which can be used in another code by importing them. The import statement is the most common way of including the functions of the module in any code. And when the module is imported, the Python interpreter searches for it, and if it's found, it creates a module object and initializes it. The math module is a standard module in the Python library, and it's always available. To use the mathematical functions under this module, you have to import the module using the statement import math. Some of the functions of the math module include the ceil function, which returns the smallest integer greater than or equal to x. That means it rounds up the number. Floor of x will return the largest integer less than or equal to x. It rounds down the number. The fabs of x function returns the absolute value of x, and the sqrt function returns the square root of x. The factorial function returns the factorial of x, and fmod returns the remainder when x is divided by y. This takes two parameters, x and y. Copy sign also takes two parameters, x and y, and returns x with the sign of y. Let us look at these functions with examples. We start by importing the math module. We're going to use the ceil method from the module to round up 45.23 to 46. We're going to use the math.floor method, the floor method to round down 45.23. We'll use the fmod method to find the remainder of 4 divided by 2. Similarly, we'll use it to find the remainder of 4 divided by 3. We'll use the absolute fabs function method to find the absolute value of minus 42.65. And we'll use the factorial method to find the factorial of 5. In each case, we are using math dot. The square root of 25 can be found using math.sqrt, and we pass the value 25. We'll use copy sign method to copy the sign, that is minus sign of the second parameter to the first number. When we execute this code, we'll notice how math.ceil, the ceil function or method, has returned the rounded up value of 45.23, while floor has rounded it down to 45. We have the fmod function, which is returning us the remainder of 4 divided by 2. There's also the remainder of 4 divided by 3, which is 1. The fabs method or function is returning the absolute value of minus 42.65, and factorial of 5 returns 120. The square root function returns 5, and the sign of the second parameter in copy sign function is now copied to the first parameter, and it returns minus 1. The GCD function takes two parameters, a and b, and returns the greatest common divisor of a and b. The POW function for x and y returns x raised to power y. IsNaN takes one parameter x and returns true if x is not a number. IsFinite takes a single parameter x. It returns true if x is neither an infinity nor not a number, NaN. IsInf takes one parameter x and it returns true if x is either positive infinity or negative infinity. exp of x returns e to the power x, where e is the base of the natural logarithm. We look at some more functions of the math module. The GCD, or the greatest common divisor of 169 and 26, is going to output 13. We use the function POW, to which we pass the values 5 and 4, and it returns 5 raised to power 4, which is 625. We have math.is not a number 23, and since 23 is a number, it returns false. If we pass a value which is a string, and even if we try to convert it to float, it will return true. If we pass a negative number, it will return false, and even if we pass 0, it will return false. We use the isFinite function with the value 5, and it returns true since it's finite. If we pass a value which is a string, and even if we try to convert it to float, it will give us a false. And math.exp1 will return e raised to power 1, and its value is 2.718 approximately. So raised to power 1 will return this, and exp2, which is e to the power 2, will return this value. The function pi returns the mathematical constant approximately 3.14159. The degrees function takes a single parameter x and converts angle x from radians to degrees. The radians function takes a single parameter x, converts angle x from degrees to radians. The trigonometric functions return the values of the angles passed to them. We look at the usage of math.pi, which returns as expected this value. We can pass a value in radians to the function degrees, and it returns approximately 60 degrees. Now, if we take a value of a variable as 60 and pass that as degrees to the function radians, it will return approximately the same value as we saw above. Now, if we want to calculate the trigonometric functions, we use the function sine, cos, and tan, and here we're going to use math.pi upon 2 to give the value 90 to sine function, and it returns as expected 1. Sine of 0 returns 0. The cos of math.pi, which is 180 degrees, returns -1, and tan of 0 will return 0. If we calculate math.pi upon 4, which is 45 degrees, the value of tan is approximately 1. The function log2 of x returns the base 2 logarithm of x, log10 of x returns the base 10 logarithm of x, and e returns the mathematical constant, which has a value approximately 2.718. We now look at the usage of the log10 function of math module, which is going to return the base 10 logarithm of different numbers. Here we've chosen to take 1000, 100, 10, and 1, and it returns the output 3, 2, 1, and 0. In case of base 2 logarithm, we take the values 8, 4, 2, and 1, and using the function, it will return 3, 2, 1, and 0. We also check the value of constant e using math.e, and it returns this value. The random module allows you to generate random numbers. For example, when we want the computer to pick a random number in a given range or pick a random element from a list. Some of the functions that the random module provides are random, which generates a random floating point number between 0 and 1, where 0 is included but 1 is not included. Rand_int of a and b generates a number which is greater than or equal to a and less than or equal to b. And rand_range is a function which has 3 parameters: start, stop, and step, and it generates a random integer number within a given range. The choice function picks a random element from the sequence which is given to it as parameter. We now look at the usage of random module. We start with the random function which generates floating point numbers between 0 and 1. 0 is included and 1 is not included. The randint function generates a random integer between a given interval. The values of the interval can also be included in these random numbers. So here we have 0 to 9, it generates a random integer 0. In the second case, we take the interval 10 to 25. The output is 12. The rand range function takes three parameters starting from the first number to the last. It also has a step size according to which it has now generated 15. And the second example has 50 to 100 and step size 2, where it has generated the number 82. With seed function, we can make sure that the random function generates the same number. For example, if we take seed 8, the random number generated in both the cases is exactly the same. Whereas when we take seed as 3, it has generated two floating point numbers which are exactly the same. We can also use the uniform function to generate a random floating point number between a given range. Some more functions of the random module are sample, which takes two parameters, population and E, and it returns a list of unique elements chosen from the population, and count of the total elements will depend on the size of E. Seed A uses the seed value as a base to generate a random number. The shuffle function takes a parameter of random list and it shuffles that list in place. Uniform function has two parameters, start and end, and it generates a floating point number within this given range. We look at some more functions of the module random, and here we've taken a list of cities, another list of numbers. Now we're going to use the function choice to select a random element from both the lists. We get the output as New Delhi. In the second one, we get 68. We can also select multiple random elements based on weightage. For that, we use the function choices and pass to it the name of the list, another parameter weights, which will basically give weightage to each element that we want to choose. And in this case, we want to choose 5 elements. So we say k is equal to 5. So that's the third parameter. It will pick up 5 elements randomly, but somehow the weightage will also make a difference to the random choices that we have. In another example of choices function, we've used the city list. Weights have been changed, and now there is more weightage given to Guwahati and Chennai, and we've chosen the number of elements to be displayed as 6. We notice that somehow Chennai and Guwahati will get featured more often in that list. We can use the sample function to select multiple random elements from a list. Now, in this case, we give the name of the list and we just simply enter a number, and that is the number of elements that will be chosen from the list. So the city list will generate 3 random numbers. So there's New Delhi, Chandigarh, and Jaipur. And in the second case, it's generating 2 numbers, 45 and 68. We've taken another list here, which has a list of programming languages, and we use the function shuffle to shuffle this list in its place. And we notice that in the output, the list has now been shuffled. We now look at the statistics module, which provides functions to be used for mathematical statistics of numeric data. Some of the functions that the statistics module provides are mean, median, mode, variance, and standard deviation. We look at mean, which calculates the arithmetic mean of numbers in a list. It could also be tuples. It could also be values in a dictionary. The median function returns the middle value of the numeric data in any sequence. Mode will return the most common data element or the most repeated data element in a list. Variance is the sum of the squared distances of each term in the distribution from the mean and divided by the number of terms in the distribution. And the standard deviation is the square root of variance. We use the statistics module to find the mean, median, mode, variance, and standard deviation of a list. In this case, we are passing a list of numbers to the function mean. It outputs the mean as 7. We calculate the median. It turns out as 6.5. We use mode, which will give us the most repeated element, that is 12. The variance for this list is 1.5, and for the same list, the standard deviation is the square root of variance, which is 1.2247, so on. So that was a little bit about the math, statistics, and random module. I hope you'll use the links in the description below, and I do hope to see you soon.